Hi, we'll talk today about radicals. So let me start with the definition of a radical. So if we have the root n of a equals p, that means that p to the power n would equal to a. Let's see two cases. So if we have the fourth root of 81, that would equal to what? That would equal to 3. Why? Because we all know that 3 multiplied by 3 multiplied by 3 multiplied by 3, that would equal to 81. This 2 would equal to 9, and these 2 would equal to 9. 9 multiplied by 9 is 81. Let's see the second case. So if we have the third root of minus 8, that would equal to minus 2, because minus 2 multiplied by minus 2 multiplied by minus 2, that would equal to minus 8. Let's see the properties of roots. So the first property says if we have the nth root of a, p, that would equal to the nth root of a multiplied by the nth root of p. Let's see an example. So if we have the third root of minus 8 multiplied by 27, that would equal to the third root of minus 8 multiplied by the third root of 27. And that would equal to minus 2 multiplied by 3. And that would equal to minus 6. This is the first property. The second property says if we have the nth root of a over p, we can just rewrite it as the nth root of a over the nth root of p. Let's see an example. So if we have the fourth root of 16 over 81, that would equal to the fourth root of 16 over the fourth root of 81, and that would equal to 2 over, so 81 is 3 multiplied by 3 multiplied by 3 multiplied by 3, 4 times. So we will get here 3 as an answer. Let's see the next property. So property number 3 says if you have the root m and inside of it we have the root n of a, so we will have the root of just the root mn of a. So we will just multiply m and n. Let's see an example. So if we have the second root and inside of it we have the third root of 7 to 9, so we will have the sixth root, because here we have 2 and we will just multiply this 2 with a 3, so we'll get 6. And the number here won't change, so we'll have 7 to 9. And if you use a calculator, you'll get a 3 as an answer. Let's see the next property. So property number 4 says if we have the root n, an, that would equal to a if n is odd. Let's see. So if we have the third root of minus 5 all to the power 3, that would equal to minus 5. Why minus 5? Because we can cancel the root with the power. So this is the fourth property. Let's see the next one. So the fifth property says if we have the nth root, and inside of the root we have a to the power n, that would equal to the absolute value of a if n is even. Let's see. So if we have the fourth root of minus 3 to the power 4, that would equal to the absolute value of minus 3, and that would equal to 3. Why? Because simply we can cancel this with this, but since the power is even, so we'll just add an absolute value to the answer and we'll get a positive answer. Let's see example number 1. So part A says if we have the third root of x to the power 4, so we can just rewrite it as the third root of x multiplied by x to the power 3. And then we can just separate them, so we have the third root of x multiplied by the third root of x to the power 3. And that would equal to the third root of x, and here we can just write it as x. So this is the final answer. Just note here that here the 3 is an odd number, so we don't need to put the absolute value. Let's see part B. So in part B we can just simply separate the root. So we have the fourth root of 81 multiplied by the fourth root of x to the power 8 multiplied by the fourth root of y to the power 4. So here we know that the answer is a 3. We solve it many times in this video, because a 3 multiplied by 3 multiplied by 3 multiplied by 3 is nothing but 81. And here, since the powers here, we have 8 and 4, so we will get x to the power 2, because we are just dividing, so we will have 8 over 4, and it's nothing but 2. And here we have y to the power 4 inside the fourth root, so we will get the absolute value of y. Let's see example number 2. We have this expression here and we want to simplify it. So we can just rewrite it as the root of 16 multiplied by 2 plus the root of 100 multiplied by 2. So we all know that we can bring 16 out by 4. So we have 4 and then root of 2 plus, and we can bring 100 out. So we will get 10, and here we have root of 2. So the final answer would be 14 root of 2. Let's see part B. If b is greater than 0, then the square root of 25p minus the square root of p to the power 3. So we have to simplify this expression here. So we will have the second root of 25 multiplied by the second root of p minus the second root of p to the power 3. So we can just simplify it more. Here we have the root of 25 is 5. The root of p is just the root of p. We cannot simplify it more. Minus, here we can simplify it. So we can just write it as the root of p squared multiplied by p. Let's see. So we'll just write this as it is, but here we have to bring p out And since p have an even power, so we have to add an absolute value, and then we will have the p. Just note here, we can just remove the absolute value because p is always greater than 0. So we don't need for absolute value. So let me just write it like 5 the root of p minus p root of p. And this is the final answer. Part C says the second root of 49 x to the power 2 plus 49. Let's see. So we can just write the second root and we can take 49 as a common factor plus 1. So we can just rewrite it as this. So 49, this 49, we can bring it out. So we'll have 7 and then we'll have x squared plus 1. Okay. So this is the final answer.